is in the millimeters, so we could capture that. Second thing is the spectral resolution. The spectral resolution is that you linked with the first slide I show you that the electromagnetic spectrum. So the Landsat 8 have 11 band. So you have seen that some visible band, near infrared, far infrared. So different types of band section is collected. So this and some sensor have lots of band, and when you deal with the radar data, you have seen that the radar image have some images have around hundreds of bands. So having the image that's define the spectral resolution. Another thing is that radiometric resolution. So radiometric resolution is little bit complex to understand. Sometimes it could be 8-bit, it could be 16-bit, or it could be 32-bit. I just shortly mentioned if image is 8-bit, so image pixel value. Pixel is that 30 meter by 30 meter resolution image. So its pixel value is highest value is 256. So if it is 8-bit image, the highest pixel value is the 256. So that is the radiometric resolution. Another thing is the temporal resolution, that's time factor. You have seen that the Sentinel-2 is 5 days. So in specific areas, after 5 days, Sentinel sensor is capturing image. So if you receive 2 days image information, so after 5 days, so next 5 days you don't get the information in these areas. So after 5 days, you got the information. So the time difference is the 5 days. So that is the Sentinel-2. In the Landsat, you have seen that the temporal resolution is the 15 or 16 days. So after 16 days, the satellite is visiting the same places. So this is the basic imagery and resolution. And finally, we have seen that where we could get the free satellite data. You know that remote sensing is very vast subject. So I just tried to very short for the discussion to give you a basic understanding. But for accessing free satellite data, you initially go for the Earth Explorer. So in the Earth Explorer, you get the basically Landsat image. Sometimes you get the Sentinel image. So for the Sentinel image, Sentinel radar or optical data, you could use the Copernicus Open Access Hub. So some NASA provided data, you could use the NASA Earth data source. Also, Sentinel Hub is another platform you could use for get access the Sentinel data or the data provided by Copernicus. Open topography is another source of data that provide the high level terrain or elevation data. Sometimes you could get access the LiDAR data. Another platform is the ESA thematic exploration platform that's provide use coastal or agricultural data. So this is the basic source for free satellite data. For paid version, you could get different types of platform that's provide the fees the paid satellite data, like some like even Earth Explorer, you could get some high resolution data when you could the purchase. So there are lots of platform for where you could get the free satellite data. So this is the primary discussion about the remote sensing. So on this discussion, I just gives a try to gives you a glimpse of uh, how things are going to happen, and how the set remote sensing data using, and the remote sensing data we could use. So don't worry, I I shared the presentation to with you, also the recording I shared to all of you. So if you have any question um, on this presentation, or any discussion on the remote sensing, you could post your question on the chat box, so that I could give their answer. And okay, if you haven't any question, then we could go for the our practice session for Google Earth Engine platform. So, okay, firstly, we are sharing all recording and the uh, handout after completing this today's session. So after today's session, you all get the handout and the presentation. Secondly, video will be shared through the YouTube platform. We are already uploaded, but we are not shared yet. So after completing today's session, we are going to share the video recording. So the recorded video and the handout also with the presentation, you all receive these things. So don't worry about this. Okay, I have get on question from Monjita for the radiometric resolution. Okay. Uh, Basically, radiometric resolution is the the image pixel value ranges. So if it is the 8-bit images, the pixel value is going to 0 to 255. So total 256 point you get. So this is simply if you go to the 2 power 8, the value is 256. So total pixel value ranges from 0 to 255. That means 256 point you may use if you using the 8-bit image. So if you using the 16-bit image, so you could simply calculate 2 power 16, the highest value you get. So the value ranges from 0 to that. So if you could use 32-bit image, so you simply using this calculation 0 uh, uh, 2 power 32. So you get that that ranges from 0 to that level to ranges value. So the if the radiometric resolution is higher, uh, you may store more information. So sometimes radiometric resolution is the factor. So like that, if we calculate the digital elevation model, and if the elevation is higher than 256, so how you could store? So as your image could not store the value, if it is 8-bit, that image could not store value 250 over the 255. So if your area's elevation is 230, 280 or 300 or 400, 500, that does not show you in 8-bit image. So for the DEM analysis, you could use 16-bit image so that the elevation is easily represented. Okay, accuracy is the different things. So, like if you collect data uh, when in the if you try to collect data in the night, so that time you are not using the active passive remote sensing. That time you need the active remote sensing like the radar data. So in the radar data, mostly through the radar band, and the reflected we are stored. So uh, the accuracy is the different context, but the thing is that if when you collect the image, what is your reason to collect that image? So based on that, you are define if you go for active or passive remote sensing. So very simply, the active remote sensing, we need need the uh, the band source from the platform that's uh, helps you to don't depend on the sun rays. So that is simply I want to say. So that is the end of our presentation. So we are go to the uh, we'll go for the okay. We are go for the uh, Google Art Engine exercise. So okay, kindly you're seeing my uh, whole screen so that are you visible my screen, desktop screen? Okay. 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 Let's discuss about the Google Earth Engine. Through the name, you now understand that this thing is developed and provided by the Google platform. So um, we are really pleased to the Google community that they are providing these things. So this is the basic uh, Windows, basic outlet of a Google Earth Engine. So if you find out, just search the Google. Okay, this is the link of Google Earth Engine. So in the chat box, I just give you the link for Google Earth Engine. So this is the Google Earth Engine information. You have get lots of information here. How how the analysis they done, what the data set. Uh, like if you click the data set, you have seen that different types of data they are provided, like climate and weather data, like surface temperature, ready-made surface temperature you get received, climate information you received here, atmospheric information you received here, weather data. In imagery section, you have seen that the Landsat image, the seasonal image, also the Modis image uh, you receive. Sometimes, if you need the high resolution imagery, you also received from the uh, using the Google Earth Engine. So this is the Earth Engine data catalog. In this section, you have seen that lots of images like crane, the digital elevation model, dams. You have seen you could analysis using the Google Earth Engine like land cover, agriculture information, the geophysical data. So this data is readily available for the analysis, and uh, this is the best vast tool. So I am just gives you a ideas about the Google Earth Engine. So you have seen that categories, all data sets. So you have seen the human dimension, that agriculture, infrastructure boundary, population, the biosphere ecosystem, forest and biomass, plant productivity, vegetation indices. So lots of information you have find here. So lots of data is now available through the Google Earth Engine. Like here you have seen that the Landsat images, collection level 2, you may get the information from Landsat 8, Landsat 9, and Landsat 7, even Landsat on 5. So you get information from 1972 to present, so through the different Landsat platform. So you have seen that currently active is the Landsat 8 and Landsat 9. Landsat 7, from Landsat on to 7 is already commissioned out. So for the current data, you mostly depend on the Landsat 8 and Landsat 9. That's the also you could use the Moody's data, Sentinel. So these are the data set, and for the high level analysis and using through your platform, you could use the different level of technology, like through APIs you could call the data. So that is the things we could use. So like that, using the data, you could use different platform, like you are using the JavaScript code for the data analysis and the data collection and lots of things. Other things, you could use the Python. So you could use the Python libraries, Colab, and also you could use the REST code. So these three the code type you could use. So you have seen that the code editor. That's the platform you have seen, that uh, uh, JavaScript editor. You have seen that this is the code editor. So you could directly go to the code editor, like code Google Earth Engine. If you have searched it, you could get the code editor Earth Engine. I am just giving also these links in the. So that is the code editor link. So you have two in this Windows. You have in the for the Google Earth Engine, you have seen 4 part. One is the left part. You have seen that you could write the script. Here you have the lots of docs which could helps you, and the asset. So this thing is the left side, and right side you have seen the inspector, console, and the task. These 3 things. I am not going to show you the details that I have due to time limit, and as I want to show you the uh, very basics. So based on these basics, you could, if you are interested, you could uh, go for self-study. There are lots of video in the YouTube based on the Google Earth Engine. Also, lots of online classes or online courses are available for the Google Earth Engine. So, in the script, basically, you are now write your code for a repository, like you have seen that username, and if I name that uh, NDBI analysis. Okay, uh, this data is stored in the Git repositories. So, okay, um, this is our path, the NDB analysis. But for the write the code, we need the file. So file is like, click here, and you have see that NDBJ analysis and NDBI. So I just name a script name that is the NDVI. If we click that, the NDVI is came to in this script. So that script we could write, and this is the JavaScript platform. So those who are very good at JavaScript, this is very easy to all of you. So for today's lecture, I already prepared the code so that I don't want to delete or consume more time. So okay. Okay, this is the basic platform. So let's try to do analysis of a uh, NDVI of our desired area. Like if I am going to any Africa region, like if I want to go for the NDV analysis in the South Sudan. So these things, you have different types of button, like so different types of, so you may give a point or you may draw a line. So when we close the line, that is the area. So you could draw a polygon, zigzag polygon line. Additionally, you could draw a polygon. So you have to see that is the square or rectangular shape we could use. So that is the total geometry. So I'm just going to delete all of these. Just okay. I just took the rectangular shape and give a rectangular area. So you have seen that the area is defined as a variable, that is geometry. I just named is a study area. So you have seen that is my desired study area. I just unset this so that it looks beautiful. So I already, as I said, that I already prepare a code for all of you. Okay. So I define the study area. So our study area is so our study area is, I just want to show you the study area. So I want to center this map in my study area. So that's why I put the command map dot center object and using the bracket and study area. And this is the value of the zoom level. So if you zoom level 9, so let's see how it's look like. So you have seen that is zoom more that our desire. So if you using the cursor, we zoom out. So 9 is very high for us. So if we go for a 12, so let's see. So that means if your value is increasing, the zoom level is higher. So for research my study area, we could go for 5 or 4. Okay, 4 is so we could use the 5 for the zoom level. So some error. Okay, like that, if you miss any command, then the error is shows in the console. So what first we think is that we center out the map. Second thing is we add layer. So in the map section we add layer, that is the our star area. So you have seen that is the add layer 1. So we could use the add layer to the study area. So yeah, we find out our study area, and we centered our study area. So second thing is that we are using Landsat 8 images. So first thing is that we called a variable called the collection, and we're using the single month, like is the November month, and uh, the the command is the EE. That means we're using the Earth engine, and the image collection command, and we're using the Landsat images. You have seen that the Landsat 8 images we collect the collect for the analysis. So for if our analysis is going right, we could use the print command and go for a let's go for a print. So what we have seen that, okay, you have seen that in the console section, the image collection is computing. So uh, problem is that there's lots of images in this section. You have seen that over 500 elements. So for the analysis purpose, we should think about our study area. Like if we go for a higher area, so sometime the Landsat does not able to provide you the desired point. So so let's go for the Ethiopian capital normalized normalized difference precision index. So so that the number of images is reduces. So if we go for a shorter area, so we go for little bit zoom in, so that okay, still it is over 5,000 elements. So just leave it, because we are going for a short in this section. So our image collection is the collected, but element is higher, so that's why our result it does not show. So now calculate the NDVI. So how we could calculate the NDVI, normalized difference vegetation index. So just okay. Let's go for a little understanding. So normalized difference vegetation index is okay. Okay. You have seen lots of history, and we are not going to. So this is the basic equation for the NDVI analysis. So for NDVI analysis, we are mostly using two band. One is the near infrared band, and other is the red infrared band. So and this is the normalized formula. So we are very easy to analyze, just near infrared minus state divided by near infrared plus state. So using this equation, the value is between the -1 to +1. So if value is higher, NDVI value is NDVI, the vegetation index is high. That means the vegetation cover is very high. If value is low, vegetation cover is very low. So the 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 NDVI is value is between 0 to -1 to +1. So this is the basic structure. So when using the as we're using the Landsat 8 image, so let's see about the what is the Landsat 8 images and its band information. Okay, Landsat 8 images band. So you have seen that we call a variable called NDVI and brings the function, and in the function we put the image and return the image. So from the image section, we in the function we call the image, and in the image we call the two band. One is the band 5 and band 4. In the Landsat, band 5 is the near infrared band and band 4 is the red band. And we rename that new image column, that image value, that is the NDVI. So firstly we define a function for calculating the NDVI. So this is the Landsat 8. Okay. Yeah, you have seen that the operational lander imagers OLI, you have seen that 9 spectral bands. So band 1 is the coastal aerosol, band 2 is blue, band 3 is green, band 4 is the red, and you have seen that the radio, the wavelength of the images, you have seen that, and in the electromagnetic spectrum, you have seen that this band, the level. So band 5 is the near infrared, so and band 6 is the short wave infrared 1, and band 7 is the short wave infrared 2. And band 8, where you have seen that is the panchromatic image, and if you have seen that all of the image is the 8-meter resolution, the 30-meter resolution, but the panchromatic pan image is the 15-meter resolution. It's little bit higher. And band 9 is the cirrus band, that is mostly used for analysis the cloud or cirrus cloud information. So we already called the function. Secondly, we do for the our desired study area. You have seen that this print collection does not give you a result because in the collection we are called whole world image for this time period. So that's why it is over the 5,000. So now we just clip the collection with the study area. So here two things happened. One is first that we call the collection, and in the collection we call the function, that is the NDVI. Then we call the mean because in over this month we found 2 times image. So we want the mean value, and the over the output we clip with study area. So now if you print the clipped NDVI, you have seen that this gives you a output. You have seen that is on band. So on band, that band name is NDVI. So as we clip with the study and we get the on band information. And if we add the map, add layer for the output, so we are going to add the clip study area. So let's run this. Okay, you have seen that we have found 2 layers, layers 1 and layers 2. We just unset the layers 1 and layers 2. So now you have seen that your NDVI is visible to you. So, and if you seen the band information, so band is on the NDVI, and your data type is float, and you have seen that maximum value is on and minimum value is minus on. So you have seen that you find the value within plus 1 to minus 1, and the value type is float. So you find the fraction value, and this is your reference system, and ID is NDVI. So uh, we find the output of our study area. You have seen that uh, for our coverage areas coordinate system. So yeah, we initially find the study find our NDVI. So okay, now you see the difference. So when you go for a test, and if you use the palette function, you have seen that the lower value is the red and the higher value is the green. Okay, you have seen the difference, the where the NDVI value is higher and where the NDVI value is lower. Okay, let's see that. So if you use the palette, you could easily visible to the NDVI open area. So now you have seen that the if you change the study area and that you just click in here, like if I want to see the NDVI of the Azerbaijan, so we just go for a, let's see, we just change the study area. Okay, and named it variable, named it change the name bit to the study area. Just run the code and you get the NDVI of the Azerbaijan. So yeah, this is so gray color because we don't apply any palette. So if you use the palette, then you have seen the difference. So you have seen that within on command you could get the data around the world just changing their study area. So if you change the study area, you could get this NDVI information. So okay, one problem we face, that's we manually changes the palette information, but you could use the visualization parameter, just command name visualization minimum 0 to 1. So beyond 0 values we could not want to see, but we want to see the 0 to 1 value, and this is the palette information. We're using the hexadecimal color code. So using hexadecimal color code, you just using this palette and show the value. So let's run this code. Okay, you have seen that before applied the palette, we have seen these types of information, but when it apply the palette, we have seen that the difference. So okay, so you could, so we want to see the satellite view because we just try to explore if our result is accurate or not. Okay, Let's zoom in this area. Oh, okay. You have seen that in NDVI, you have seen the very dark green color. That means these areas have more vegetation. But this is the white color. So here we have not any vegetation. Rather, here we have found some water bodies, because when we use the near infrared, the water reflectance level is high for near infrared. So yeah, we could use this palette and just run this code and able to find the anywhere in the world. So you have seen that how things are going to easy. If just you are select your desired area and just run the code and find the study area. So sometimes we need the output. So yes, still this is in the server of the Google Earth Engine. So we need for the further analysis or further output. So we need to save the or export the image information. So we're using the export function. Okay, export image to the drive. So there are lots of way to export, but very easy to export to the your Google Drive. So the export image to Google Drive. So your you have seen that you are connected with Google ID. So this image going to your the ID you are using here. So okay, let's see that what we want to store, that is the image, and we use the clipped NDVI. That is our simple output, the clipped NDVI. Description, we put the name, the NDVI study area. Scale is the 30, that is the resolution. You already I given you that the information you have found, that data type, transformation, NDVI, and the dimension and origin. So the band information you have find the 30 meter by 30 meter. So that's why you are using here the resolution is the 30 meter. Second is the region. So we want this region, the study area. So that is our interstate area. So you need to save as a file format. So our file format is a geotip. So it is very easy to analyze the geotip format. And the folder, so we're using a folder that is the time series NDVI. So if you click the run, yeah, we get this output. And you have seen that in the task section, you have seen an unsubmitted task. And if you run this time series NDVI, so already this folder in my lab computer, already in my drive. So yesterday, yeah, I just renamed the file name and file format. You have seen the geotip. So you have using the tip recorded image. So if you run this, you have seen the information you given that is the already in the section. So let's wait for this run. This may take some moment. Okay. Okay. Don't worry. I shared also the code to all of you. So Okay, some people is still facing to join, but I don't know why. Already lots of people are joining with us, so I don't know why you face challenges. So, so but so for that's our the first part, last section, that is the NDV analysis. So I am going to share code with all of you. So you could just um, analysis and login analysis using the code. So let's when output is ready, I will going to show to you. So we are just complete our first part uh, of today's session. In the second part, we have a short discussion on the use of GIS and remote sensing development sector. So let's go for another presentation. Okay. Am I still audible? So no one is saying something. Are you seeing my screen or presentation? Yes, anyone? Okay, okay, okay. Thank you. Thank you. Okay, thank you. Lots of people are still active, but I am little bit worried about, are you still on with us? So thanks those who are still show the patience to with us. So this is the second and the last part. So applied GIS use case. So in this section, we are mostly discuss about how different way we could use the GIS and remote sensing in our different sectors. So this is the major objective, to share all of you how GIS and remote sensing could help us to make decision, could help us to uh, easier our life for those we are working in the development sector. Uh, so firstly, in disaster risk reduction, so uh, in the disaster risk reduction, one thing we are doing, that is the hazard, vulnerability, capacity, and risk assessment. So different way we could do this, like flood hazard mapping, the exposure area. Like we are uh, analysis the NDVI, same way we could use the flood mapping or flood exposure areas. So when my output is ready, so I am going to share with you the how uh, we could analyze how we could get the information about flood mapping, so that we could get the information. Another thing is the identify the most vulnerable community. So for the most vulnerable community, we could use different types of information, like uh, we incorporate the income data, we incorporate the livelihood data, we incorporate the hazard or risk data to identify the vulnerable community to the different hazards or the shocks. Additional thing, we could do the mapping the capacities of the resource. So when we do any response to any incident or any disasters, so we need to clear about the information of uh, the resources. So if you have a quick access to resources, so you could do a quick decision making, so that to uh, for all of us, so that very easy to or relieve the human community life. So these things you can do. You can do some additional things like the find out the most affected areas. Like if any flood is happened, which area is under the flood, or which area is still not flooding, or which areas is going to flood it in the upcoming days. So uh, uh, we could do these things very easily using the GIS and remote sensing. So these things are very easy. Here you have seen that the map of the uh, uh, risk map of the Bangladesh. You have seen that the districts wise the risk map, or the administration level 2 level of risks. You have seen that the higher risks are showing the uh, very dark color, and the lower risks is showing very light color. So uh, using the different types of data, you could very easily get access the uh, uh, get the information of the uh, uh, risk area, and you could visualize using the GS tools like like the QGIS, ArcGIS, and lots of tools. Even you could use the Google Earth Engine to visualize this. So to analyze this, to do this analysis, what kind of data we initially needed? You have seen that we needed the base geographic layers, like the boundaries, like the road networks, the river networks. Sometimes we need the digital elevation model. Uh, so these things that gives you the a basic understanding or basic ideas about the topography or base geographical condition of your area. Second thing, we could use the uh, second thing we could easily um, do using the uh, like uh, um, hazard data layer, like the flood zones, landslide susceptibility, or storm surges track, where the also the path the path of the storm surges. Uh, so uh, these types of data we could easily uh, find out and analysis. Second thing we could do, that is the uh, 1 minute, please. Okay. Okay. Second thing we could do, that is um, the vulnerability data. So like that, the population gridded data, building footprint, poverty data, uh, livelihood data, or lots of vulnerability data we could incorporate. Uh, for risk analysis, we could use the capacity data, like the uh, where the shelters or the safe places, or the clinics or the health facilities, or where the fire station or the uh, local civil services offices. So we could incorporate all of this data and do analysis, and finally we could find out this kind of thematic maps. So, so basic workflow for the hazard vulnerability capacity risk mapping. First thing is that the data collection and input. So we could use the different types of data collection and use for the analysis. Second thing is the layer standardization and classification. So you are collecting different types of data, like the remote sensing data and GIS data, and then you need to standardize same format and need for the analysis. And finally, do a overlay analysis, where you could easily do that analysis. And finally, find out the hotspot identification, where the most vulnerable area and where you need to focus fast. and where we need to go for the intervention, like the previous maps. You have seen that the higher vulnerable area is showing the dark color. So if you go for intervention, you should consider this vulnerable area. You should consider this area for your intervention, for your action, so that you could do that. So this kind of thematic output you may receive finally as a hotspot or identification. Second thing, we could do analysis for the slum mapping, sanitation coverage, or service gap. So, in the slum areas, you are not able to frequent visit. So, if you have some base information or data, then you could easily get ideas about slum information. So if you want to develop a analysis in the slum areas. So first thing, you could collect the high resolution satellite imagery to uh, easily delineate or get the boundary of the targeted study area, so that you do analysis your actions. Second thing is that the sanitation coverage. So if you have GIS area like that, the pipe water network or the toilet facilities location. So if you have that information, the toilet facilities location and the population footprint. So we using that the population footprint and the toilet facilities or sanitation facilities location, so you could easily analyze the coverage area, so that you could do analysis. Uh, Third thing is that identify the service gaps. So if you have the administrative boundary, if you have the people location footprint or people houses footprint, and if you have the facilities location, then you could easily find out the gaps where the people are still out of our service or out of your sanitation facilities. So then you go for the intervention for this for that area. Okay, basically simple concept of wash mapping. Firstly, I already mentioned that you should digitize the informal settlement using satellite imagery. That the higher resolution image gives you a leverage to do that, so that you could get the accurate spatial data of the slum footprint. Second thing is that the sanitation coverage measured by mapping latrine or septic tanks or the sewage network or community or coverage area or uh, the the water service network. So using all these things, you could analyze the coverage area. Finally, you could identify the service gaps where still the people are out of our sanitation services, where the sanitation services need to improvement, or where the people should think about take consideration about the um, ideas on the uh, ideas on the when you need to intervention. So this information you could easily get. So for the data preparation, wash analysis. So already mentioned that base imagery or base information you needed. For that, you use the recent satellite images or drone images and digitize the boundaries mapping features. Second thing is that the facilities mapping. You just uh, facilities point mapping. Second, then we could use the mapping sanitation infrastructure like latrines, the walls or water point, or the public toilet or toilet facilities using the GIS or GPS tools to collect accurate point location. Then we could integrate the population data with all of this data. So with then we could easily measure how many people are still using our toilet facilities and how many people are still out of toilet facilities. So when all of this data is collecting, so important thing is the accuracy. So when your collected data is accurate, then it is then your output is very accurate. So always try to collect accurate data. So practically, what do you think do? So digitize or imported polygons of SLAM boundaries and load the 50 latent location for a special analysis. Then we could create a buffer map like a toilet facilities or a latrine could cover the 100-meter areas or 20-meter areas people. So then we could do for a buffer analysis. So after doing the buffer analysis, we could get the access like uh, the areas already covered and areas out of the service. Then function that clip the buffer, then we find out the gap identification. And that if we get the gap of our service, then we could do for a plan for the sanitation or target or facilities. So here we just give a simple workflow. That is the digitize the SLAM boundaries. Second thing is the mapping the sanitation facilities. Third thing is creating service area buffer, and fourth thing is the conducting gap analysis. So this is the simple workflow uh, for sanitation analysis. Same thing we could do the health facilities or health facilities catchment or access of health services. Uh, like catchments are simply the areas our health service covers. Like if any areas the uh, health service is already defined, health service already reached or not. So like a health center is set up to cover a certain areas. So if the health center is uh, uh, far situated in far areas for the people that did not get access. So then analysis the access the inequality. So which area get more access to the facilities and which areas are not. Then we could analyze the health accessibility. After the output, we could plan for the accessibility planning, like in which area we could do more intervention and more focus to get the better results. So for this analysis, what kind of data we needed? Like firstly, we needed the facility location data, like where your health center is located and where uh, your hospitals or clinics is located. Second thing, you use the road network because to access the health service, you must have some uh, better accessibility in the road. So you have that data of the road network. Uh, Third thing is that information you needed, that is the population distribution. So you have the population data of the study area or the assessment area. So uh, and another information may help you to get better result, that is the elevation or and the land cover, because sometimes the distance is very low, but due to the train or high areas, people are not able to get access the health facilities. So if you have these types of four information, you may get you may assess the health facility access analysis. So these types of information is needed for analysis. So what is the workflow? Initially, we need to develop a network dataset uh, to with the travel speed, like how many times you needed from your location to the health service center. So if it needed the higher time, it uh, gives you a barrier to get the quick access to health services. Then we could analyze the service area, like the catchment. I have a point file or point shape of a hospital. Then we could do buffered analysis that this hospital may service the 10 kilometers radius or the 20 kilometers or the 5 kilometers. So in which level this health facilities provide services. Third thing is the population coverage. Uh, the population is not evenly distributed, that is the unevenly distributed. So we need to overlay the population data so that we could easily visualize the where our health center is located and where our population mostly are located. And with the road network, we could easily get identified the which people are still facing the challenges to get the health facilities information. So this is the simple workflow we could use to uh, uh, analyze the health facilities, health inequality or health accessibility. Uh, so in practice, what we could do, we could do like build a network of dataset where the 30 kilometer power on paved road and 10 kilometer power for unpaved road for analysis. And we are analysis on our service area because within 1 hour which people get access the health facilities. And next we could use the population coverage analysis, how many people are already covered uh, within 1 hour service. And our road network is two types, one is 30 kilometer per hour and other is 10 kilometer per hour, one is for paved, one is for unpaved road. And finally, get information the access inequality hotspot, which areas people are still face challenges to get access the health facilities or health facilities information. Finally, uh, we could analyze the humanitarian response like camp coordination and therapy mapping, resource distribution. So this information helps you a lot. You have seen you have seen a map, that is the UNICEF provided map for the uh, largest refugee camps in the world, that is the Rohingya refugee camps. So the 3W map is giving you information which information is where and for what. So uh, this 3W maps helps you to identify the location of different services, location of the people, location of of your most vulnerable people. Uh, Simple things, you're using the lots of GIS enables mapping the refugee camps for better coordination, and theoretical map is identify who is doing what and where. That is helps us to provide our services very for the evenly distributed all over the people, because without this information, the people who are not get the information, uh, they got not within cover of the services, they are facing the challenges. Second thing is the resource distribution, because this helps to track a resource is located and identify gap where the resource is needed. And based on this information, you could do a plan for the further improvement. So what kind of data preparation needed? So one thing is needed, that is the camp level layout data, the area of camp boundary, the camp block level or sub block boundary. Second thing is that the agency activity or service point, different types of agency and different types of service we have. So we need to understand about need that data, the agency service point. And thirdly, we need the population data, uh, the refugee data. So where they're located, where the shelter footprint, and also we needed the road and the footpath location. So what is the basic workflow? One thing is first we do the camp mapping to identify the symbology of shelter, block, sub-block boundaries. Second thing, we do the agency or activity mapping, where agency are the located and where they provide services. Um, then based on this information, we are plan for resource distribution and also the monitoring. So this thing helps a lot to effective coordination and effective uh, effectiveness for the people who are the most vulnerable. So there's the basic understanding about how we could easily do analysis or do access or do applied GIS in different sectors. So this is the end from myself. So we are go for a short Q&A session. So I am just requesting you put your question in the chat box. Uh, uh, Raising your hand. So those who are raising your hand, please put your question on the chat box. Okay, one thing is that, yes, we have a assessment. Yes, we are doing a assessment, simple assessment, and I am putting the link in the chat box uh, within 20 minutes, like uh, within 11 p.m. you will get the your assessment link. So one question is received, that is that do GIS generated data different from meteorological forecasting data in predicting flood associated disaster in a specific area? Here is two things. One is the meteorological forecasting data. So in the meteorological forecasting data, you may visualize the output in GIS. So, but it is not mandatory to visualize the in the GIS, but the GIS platform helps to better visualize and better reach to the people. So still these are not dependent. GIS data is different, but meteorological forecasting data is different, because meteorological forecasting is comes from different way, like different bulletin style. Just they are saying this area is flooded, but in some cases you have seen that the some meteorological forecasting data you could get output as a output in the backend information is that the GIS. Like one thing is that uh, one thing is very easy, like that Google is already given the flood alert to using the exposure zone. So Google is already providing flood forecasting. So through the Google Research Lab. Uh, so they are using the GIS information for the visualizing the flood in the world.